property. So, in that case it is essential to use some amount of the shielding gas, and even it is possible to using the shielding gas that the weld joint properties is as maximum as of the basic properties of the parent metal. So, therefore, this investigation actually indicates that there is a need of the using the shielding gas in the welding processes. But if we look into the overall effect of the nitrogen, oxygen and hydrogen on the weld joint quality, because these three components in the atmosphere or surrounding atmosphere mainly becomes part of the final weld joint. So, they are having some impact on the weld joint quality. So, in overall if you see that if you look into the steels, that steel presence of nitrogen actually when it is contaminated with the nitrogen, it increases the strength, but reduces the toughness. So, increases the strength, presence of the nitrogen increases the strength of the steels because there is steel containing of the other alloying element. So, that increment of the strength actually depends on the nickel and chromium ratio presence in the different graded steels basically. So, that this is the effect of the nitrogen only, but of course, they are in presence of other alloying elements also important. In general, presence of oxygen in steels basically drastically reduces the toughness, but improves it, that means toughness can be improved if acicular ferrite is promoted. So, we can control the solidification process in such a way that acicular ferrite is promoted, then probably the toughness can be increased even in presence of the oxygen. That means, even it is contaminated with the oxygens. Hydrogen basically the role of the hydrogen in steel during the welding process is try to induce the hydrogen cracking, that is normally we can say that it is a cold cracking process. So, basically these are the role of the nitrogen, oxygen and hydrogen, and in presence of that what types of the properties can be affected when you try to weld the steels. Now, austenitic or duplex stainless steel. So, austenitic stainless steel and duplex stainless steel basically the most influencing parameter is the nitrogen here rather than oxygen and hydrogen. So, basically in presence of nitrogen, the austenitic or duplex during welding of austenitic and the duplex stainless steels, that actually reduces the ferrite content and provides the solidification cracking, or we can say the hot cracking. Basically, chances of the hot cracking actually enhances in presence of nitrogen during the welding of austenitic or duplex stainless steel. Then aluminum, definitely when you try to weld the aluminum, most serious problem is the formation of the react with the oxygen and formation of the oxides. So, that oxides can be trapped within the molten pool and becomes part of the final weld joint as an inclusion. Therefore, in welding of the aluminum, the contact with the oxygen is better to always avoid, because oxygen has the high affinity to react with the aluminum specifically, and this affinity increases with respect to the temperature, and so forms the oxides. So, that is the one serious problem welding of the aluminum, making the aluminum oxide, and other hydrogen is also having effect during the welding of the aluminum, that it actually forms gas porosity and reduces the strength and ductility. So, when there is a presence of the gas porosity within the final weld metal component or final weld joint, that trapped porosity actually reduces the mechanical properties like the strength properties and of course, the ductility. And other material, specifically the titanium. So, titanium is also having when it interact with the oxygen and mainly oxygen and nitrogen. So, presence of hydrogen is little bit affected in the titanium, joining of the titanium and their alloy. So, that is more serious problem in case of welding of the titanium, and it is a very proper shielding is required to avoid the interaction with the oxygen and nitrogen from the atmosphere. So, probably it is more serious problem the shielding as compared to the steels, or probably as compared to normal steels component. So, sometimes in welding process also practically we have seen the welding of the titanium links, the extra sealing gas is sometimes required simply to protect the molten pool, because it is having very high affinity to form the to react with the oxygen and nitrogen, and basically when it react with the nitrogen molten titanium, that actually increases the strength but reduces the ductility, or we can say that sometimes it actually decreases the strength as well. Even for oxygen also it increases or decreases the strength, but definitely reduces the ductility. So, we can see that of course, almost all type of materials, ferrous, non-ferrous, that during the welding process they are having the tendency to react with the surrounding atmosphere, and most of the cases we can find out they actually reduces the mechanical properties in presence of these different atmospheric elements. So, therefore, to protect this all these elements from the atmosphere, we generally use the shielding of this molten pool in a different way. Some overview on these things, the effect of the chemical reaction in oxygen in welding, and here we can see that oxygen and nitrogen levels at the during the welding process we generally find out the different welding processes, the what is the x axis and y axis. X axis represents the nitrogen position and y axis represents the oxygen component, percentage of the oxygen component. And here you can see that submerged arc weld, in case of submerged arc weld, presence of nitrogen component is less during the welding process, but presence of oxygen content is more in here in the submerged arc welding process. Probably in submerged arc welding process we can use the slag material or we can use the some flux material, and that flux, one of the component of the flux may be the oxide. So, that oxide is a supplier of the much amount of the oxygen presence in the weld pool, but the nitrogen level is very less in submerged arc welding process. If we look into the gas metal arc welding process, here also oxygen content is little bit more as compared to the gas tunnel arc welding process, because gas metal arc welding process sometimes commercially we use the shielding gas as a carbon dioxide. So, that carbon dioxide basically react at the high temperature and it can form the oxygen, and that oxygen can be a form of part of the final weld joint. So, GTA welding, the relatively the oxygen level and the nitrogen level is relatively less, because in this case we do not use any slag and we use the inert type of the shielding gas. In this case, the inert type shielding gas actually protect the molten pool from the outside atmosphere, and even that inert gas also do not try to react with the molten weld pool. So, that is why argon shielding gas used in case of the gas junction arc welding process. So, that the oxygen content and the nitrogen content in the final weld joint is very less in this case. Shielded metal arc welding, we use the shielded metal arc welding some coated electrode. So, here that molten weld pool is basically protected by creating the slag as well as the formation of the fume or gas basically. So, that protect the molten pool, but in this case here the composition of the coating on the electrode, that actually that can be different composition, and that can also act as a source of the oxygen also, and that oxygen can be become part of the final weld joint. So, it is a moderate type of oxygen and nitrogen content we can find out in case of shielded metal arc welding process. But if you look into the self shielded arc welding process, so in case of self shielded arc welding process, in this case it resembles that it creates the arc like gas metal arc welding process. There is a continuous supply of the electrode in case of shielded metal arc welding process, self shielded arc welding process, but this use not any kind of coating on the it use the coating of the electrode, and that actually protect the molten pool, but it is some very little difference with respect to the shielded metal arc welding process as compared to the and as well as compared to the gas metal arc welding process. So, here shielded metal arc welding process we can find out that moderate amount of the oxygen content may have, but nitrogen content becomes more in this process because of the process itself. So, although we can use the shielding gas and different type of protection, we can use the flux also, to protect the molten pool, but till in the final composition of the weld joint may have some amount of the oxygen and the nitrogen, and that different welding processes, what are the typical content of the oxygen or nitrogen, some idea we can get here. So, overall we can see that overall all this process we can find out the least amount of the oxygen hydrogen content, probably we can find out in case of gas metal arc welding process, and we can find, but maximum amount of oxygen content we can find out the submerged arc welding process, and maximum amount of the nitrogen can be find out the self shielded arc welding process. Of course, this amount of the oxygen nitrogen content not only depends only on the shielding gas, but it also to some extent depends on the what type of metals we are just trying to weld.